In order to understand how blockchain works, it's important to start on the hash level. And what a hash basically is, it represents the result of the encryption that is realized through the algorithm that is predefined in that particular blockchain. And what this does is that basically the hash takes any piece of data, and this can start like from a number, a series of numbers, to an unlimited library. And what it does is that it transforms all this information, no matter uh, how extensive, into an identical length code that seems apparent, a combination of letters and numbers that seems purely random. But what the magic of this hash is that the encryption works in the same way. So basically, if we were to, and every time like there's a new piece of data added to the hash, the entire code changes. But what's interesting about it is that using that particular hashing method or algorithm for that particular blockchain, the same data will be encrypted in the exact same manner. So if we were to rewrite it as many times and have the exact same piece of data, it will be encrypted into the exact hash. And what the hash basically does is that it becomes part of the block, and the central elements of a block are the block number, the block nonce, which is basically just another number that defines that particular block. I mean, in a way, it represents the number of calculations or the number of trials until until that particular right combination was found and the block was validated. Then there is a piece of data that we were discussing in that gets encrypted, and then there is the hash part in which that defines the block and ends up validating it. And how this plays into the blockchain is that obviously a blockchain is a chain of these previously described blocks that are interconnected. And the difference between the blockchain and the blocks is that basically a blockchain includes all the information that's present in the block, as in every block contains the block number, the block nonce, the data that gets encrypted into that particular block, the hash, but also the new element that gets included into the blockchain is the previous hash of the hash of the previous block. And what's special about this is that there is one inception block that just contains a random that basically contains the algorithm that for the foundation block, and from that the blockchain gets generated. And in order for a transaction to be validated on the blockchain, it needs to satisfy the previous transaction. It needs to satisfy the previous hash of the transaction. And when data gets, for example, modified in one of the blocks throughout, like if there are, let's say, 5 blocks, data gets modified in the third or in the fourth block, automatically all the blocks following that transaction will be invalidated, because the previous hash will not match again the previous hash of the hash of the next block in its field. And because of that, the transaction and the block will not be validated by the blockchain. And what happens then is that the miner needs to basically mine and refine the operation that would get validated, and so that the block that firstly got the first block that got invalidated needs to be revalidated. And after that, like the miner can for the next block can start validating based on that new hash. They can start validating new blocks into the chain. But what happens in a decentralized network is that basically the system works in exactly the same way, but there's numerous peers that have this exact that have a copy of this blockchain in their devices. And what this does is that this property of being copied throughout every single node, every single peer, and there are extremely many peers, extremely many nodes. This ensures that whenever a node or a number of nodes might be corrupted, the rest of the network has to reach consensus before the next block gets added, so that even if there is like one miscellaneous transaction, it will on one of the nodes, and it might get accepted on a particular node, and other nodes start flowing because of the rule of the longest nodes, and then like the longest series of nodes. That particularly problematic transaction will not get validated when the actual block will not get added to the blockchain, because it will get compared to the series of blockchains, and the series like with the longest transactions that were accepted will be accepted as a general truth based on the algorithm of the blockchain, and that ensures the safety of the transactions.